Hello, everybody. Welcome to the presentation of our demo paper entitled Coupling Similarity and Diversity for Clustering Multivariate Astrophysics Data. My name is Gosia Tracheski, and this is joint work with 6 undergraduates and 2 graduates from Iowa State, and the 2 teams of researchers from Northwestern University and University of Geneva in Warsaw, Switzerland. Now, what motivates our problem? The stellar evolution basically can be captured as multivariate time series, which has a very, very large number of parameters. Typically, the evolution stages go through several distinct stages as the parameters evolve, and then as the internal processing, something like helium, nitrogen, carbon concentration, radium, masses, and so on, evolve. Now, typically, the stellar dynamics is investigated by theoretical astrophysics, which uses analytical computational models from different branches of physics, and observational astrophysics, which basically uses different technologies to record and interpret data. However, one of the problems with observational astrophysics is that it has limited spatiotemporal horizons. Therefore, scientists in astrophysics are often using simulation data, one popular tool being the MESA tool. This way, they can generate even larger data set and test their hypotheses and models. Such data sets are tens, 20s, and multiple tens of gigabytes. However, they also have over 40 and sometimes over 100 attributes. Now, this work is part of the Poseidon projects, which all of you are welcome to go and check independently. Now, the crux of this work is that sometimes astrophysicists may be interested in clustering the stellar evolution data. However, oftentimes they may be interested in the impact of only a few attributes, and sometimes they want to have certain attributes close, but certain attributes as far as possible, which means the distance function should be forced to grow. For each attribute, what we do is, since they're heterogeneous, we first detect the min and max values, and then we relativize, thereby making them dimensionless. And then the main twist of the clustering that we introduce is, the traditional distance function, which we do Euclidean over relativized values. What we do is we add weight to the attributes. Most importantly, if the diverse attributes are to be properly taken into consideration, we have a threshold which says if those two values are closer, then their constant should be set to a very large value. As far as system architecture is concerned, it is of a client-server type broadly with backend and front end. However, I invite you to visit the URL specified in the paper, where you can find a lot of details about design documentation, interface, and testing. So, demo time now. This is the interface of our system, where basically the opening menu gives you an option and list of, adding a new data sets, looking at a help guide, and doing administrative functions. What we're showing here is basically, creation of a new data set. We have already a few ready ones, but now we're creating a new one from the CSV files that are exported from the simulation. For this purpose, we're creating a rather small file. And now that the file is created, we can see it in the main menu first, that it is available. But before we go there, we need to specify how we're going to store it. This is a demo data set, and a little bit of a description. Now, the simulation fields, they come from the header of the CSV file. Most notably, the file ID and the node ID are the simulation number and the unique simulation identifier in terms of the temporal dimension. And then we can go ahead and select attributes from the CSV file which we want to be converted to database values. So we're selecting mass, luminosity, radii, and a few others. Once we submit, we see the process of creation of our data set. Again, this process takes quite a while longer if we choose a larger source data set. One thing that I would like to point out is that every now and then there may be a little bit of a discrepancy between the number of tuples in the database and the actual size of the CSV file. That happens when we have division with 0 or something like that. Some kind of an error has been detected. Now, with this in mind, as we can see, the demo data set is part of the main menu, and we can use it as we will. The heart of this demo is right here, where basically now we see all the attributes that we selected, and then we can choose the ones that we want to accentuate their impact on the proximity, and the ones that we want to accentuate their impact on the diversity that we want them as far as possible. At the bottom part, you can see the selection of a time frame, as well as the parameters of the clustering algorithm. In this case, it's k-means, and we want 3 clusters. So we show here the output visualization, and we can increase the number of, we can modify the time unit, we can increase the number of clusters, and we can actually do even 3D visualization, which basically sums up the heart of the functionality for clustering. We also have a very detailed help menu, as well as, the administrative functions that can be readily presented. At this point, I'd like to thank you very much for your time and attention. And whenever appropriate in the session, we'll be happy to take questions.